What does the power of 0 get us? No matter how big or small that power of 0 is attached to. What is the answer to the power of 0 all the time? No, power of 0 is not 0. Go back and look at your notes from on Friday, it looks like. Don't just sit there guessing stuff. Power of 0 is not 0. Okay, nope, not the same number before the exponent. Go back and look. What does the power of 0 get us as an answer? Doesn't stay the same, no. Power of 1 stays the same. No, go back and look at Friday's notes. It's in there. Don't want people guessing. If I already said 0 is not the answer 3 or 4 minutes ago, it wouldn't be the answer now. Remember, we did the ones where we did the pattern. And that was Friday. Look in the pattern for what the 0 powers got us. Because the power of 1 is the base number. The power of 0 is something different. And we know negative exponents get us what kind of numbers? Anything to the 0 power. Not Friday, Thursday. My fault. Anything to 0 power is what? What kind of numbers do we get from negative exponents? So there's 2 different questions out there right now. Power of 0 gets us what number all the time? No matter how big or small that power of 0 is attached to. It will always end up with what answer? 1. Yes. Because remember, when we're finding and using the exponents, we're dividing by the base. So the first power gets us the base. Well, if I divide the base by the base, which is 0 power, I get the number 1. Okay? What kind of numbers do negative exponents get us? What do they look like? What do the negative exponents answers look like? Decimals and fractions, yeah. Okay, so now I'm gonna go back to here. Okay. So the whole purpose of scientific notation is because in science, we have things that are super, super tiny that we measure, or super, super gigantic that we measure. The universe versus the microscopic. And in order to have those numbers be on the page and not be this gigantic, cumbersome number, they came up with scientific notation. Each number of our system is based on 10. We're a base 10 numbering system because we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 pieces. We are base 10. So when we were looking back at this one that has this base 10 right here, right? That's what our numbers are going to be doing. Okay. Positive exponents mean I'm multiplying by 1,000 or 100 or 1,000,000, depending on how high the positive goes. Negative exponents are those little tiny decimals. Okay. So we're going to be rewriting in scientific notation because we need the numbers to be manageable. That's the whole point. We need the numbers to be manageable. And to be manageable, we need to have them written in a format that doesn't use up the whole 7 pages of the paper. So to change a number from decimal form, this is called decimal form, standard notation form, to scientific notation, we are going to jump the decimal, okay, so that we end up with only one number behind the decimal point. And then we're going to count, and that's going to help us with our exponent. So let me zoom in a little bit. My decimal is currently right here. I'm going to jump, and I'm going to count as I jump how many jumps I take until I have a single number in front of the decimal place. So how many jumps did we take so that we got a single number in front of the decimal point? Let's see. 1, 2, 3, 4, 5, 6, 7. I don't think it was 8. 1, 2, 3, 4, 5, 6, 7. A single number in front of the decimal place. Okay, that's our goal. A single number in front of the decimal place. So that would be a 7.86, a single number in front of the decimal place, times 10 to the, how many jumps did we take again? That's 6 zeros, and then the 7 makes 7. And we went from a decimal, so it's a negative. Because remember, the decimals were the negative exponents, and the big numbers were the positive exponents. Okay? So all you're doing is jumping the decimal, and then because it was a decimal form to start, it's a negative exponent. If it's a whole number form to start, it's a positive exponent. Okay, do we have one number in front of the decimal point for this particular problem? Here. Because to be scientific notation, we have one number in front of the decimal, and that's it. Do we have a number in front of a decimal and only one number in front of a decimal? Yes. So this is going to be 4.7 times 10 to the first power. Oh no, to the 0 power, because we just need 4.7. That's why we had to remember that 1. So if we don't have to make a change, it's times 10 to the 0. If we do have to make a change, it starts as a decimal, then it's a negative exponent. It starts as a whole number, then it's a positive exponent. But we didn't have to jump any decimals, so we jumped 0. Remember, the exponent is how many jumps we took. Since we didn't have to jump, 10 to the 0. Okay, we're going to do our jumps. We need it so there's one number in front of the decimal point. Okay. Then we write that. So this is 6.0 times. Yes, we're using that x times 10 to the. Okay. How did it start? Did it start as a decimal or did it start as a whole number? Was its original form a decimal or a whole number? Decimal. So am I going to be a negative or a positive exponent? Negative, because it started as a decimal, exactly. How many jumps did we take? 2. Yep. So if it starts as a decimal, it's a negative exponent. If it starts as a whole number, it's a positive exponent. And the exponent is the number of jumps you have to take. Okay. So that's going from standard form to scientific notation. Now we have to go back. We're starting with something in scientific notation, and we want to turn it back to the number it would be if we wrote it all the way out. So we're going to do the reverse. we're going to look at our exponent and we're going to jump our decimal so that it recreates the number. Now, if the decimal is positive, then we're jumping right because we're creating whole numbers. If the decimal is negative, we jump left because we're creating a decimal. So we're going to put a note in. Positive exponent, jump right. Negative exponent, jump left. Okay? So we're going to jump our decimal. In this case, it's a positive exponent, so we're jumping to the right, the number of the exponent, 3. So 1, 2, 3, and I do have to fill in the blank with our placeholder number. What number do we stick in place of spots? What number holds things for us? So 6, 1, 7, what would I put? Because I have to show I did 3 jumps. So what number was there after the 7, even though we didn't see it? When we write out our numbers with our decimals, what can we put at the very end of a decimal? Because it doesn't change anything. What number holds places for us? 0. So you do have to account for the fact there was only 2 decimal places here and I had to jump 3, so I had to put that 0 in. Okay, which way am I going to jump for this one? Left or right? Right, because it's a positive. So if I jump right, 1, 2, 3, 4, 5, 6, right? What am I going to fill in those jumps that I don't see a number with? What do we fill in the blanks with? What number do we fill in the blanks with? We just did it on the last problem. Zeros. So how many zeros do I need to fill in the blank with? If I had 2 decimal places and I had 4 jumps to take, 6 jumps to take, that means I had 4 zeros I need to fill in with because 2 got used up for the decimal point. That's a comma. Okay, which way am I jumping? Left, because it's a negative exponent, exactly. I'm jumping 3. So 1, 2, 3. Oof, try again. I'm gonna try again. That's horrible. Okay, 1, 2, 3. That's bad, but it's okay. Okay, what do we fill in the blanks with? What do we always fill in the blanks with? 0. So how many zeros do I have to put in front of that 6? 1, 2 of them. Because I had 2 empty spots, right? So I had the decimal, 2 empty spots. I realized I want to put one of these notes like this up above here. So let's move up here. Oops, that's a text box. Now, the thing that works opposite when you're creating. So positive exponents jump left. Negative exponents jump right. So when you're creating the scientific notation, negative exponents are jumping left, right, and positive exponents are jumping left. They have to do opposites. They undo each other. Okay. Write each in scientific notation. What? Aren't these already scientific notation? They have 10 to those in them. Aren't those scientific notation already? Think back to what we said the format was. Are these scientific notation just because they have 10 to this? Because what was our format? One number in front of the decimal point. Does 13 have a number in front of the decimal point? No. So it's not scientific notation, even though it says 10 to the. We have to fix that. Which way are we going to have to jump to fix this so it has one number in front of the decimal point? We have to jump it right. Okay, we have to jump it to the right. So I need one number in front of the decimal point to be scientific notation. But when I'm building scientific notation, it says if I jump to the right, I'm a negative exponent. So that means I have to subtract one from this 6 because they did one too far. So let's put our note. Except this one's going to be slightly different. Okay, so for this one, you subtract from exponent if you jump right, and you add to the exponent if you jump left. And it is the same number of jumps. So if you jump 2 times, you add 2 to the exponent. If you jump 7 times, you add 7 to the exponent. So I jumped 1 to the right, so I have to subtract 1 from my exponent. It got written incorrectly. They got too crazy, did too many jumps. This should have been 2.0. Oops. Times, maybe, come here. Ten to the 5th. They jumped too far. Okay. Do I have one number in front of my decimal? And only one number in front of my decimal. Do I have one number in front of my decimal? And only one number in front of my decimal for number 15. Look at 15. Is there a single digit, a single number in front of the decimal point? No. I see 8. That's 2. That's not 1, that's 2. So we have to fix that. We can't have 2 in front. We can only have 1 in front. Okay? We can only have 1 in front. So we have to jump our decimal. Which way do we have to jump our decimal? Which way do we have to jump our decimal? To the left. If we jump our decimal to the left, what are we going to do to the exponent? We're going to add to it. So we have 8.84, that was the one jump, times 10 to the How many jumps did I take? One. So I'm going to add 1 to the exponent, 4. Okay. So this is correcting people made mistakes when they were making the scientific notation. And how do we fix it? Now, these last few, we're going to do some math. And the first thing we have to do is move like things together and deal with them. Okay. This is all multiplication. The whole thing is multiplication. Parentheses means multiply. The X symbol means multiply. All of that means multiply. And with multiply means we can shift things around and it doesn't affect us. It just makes it easier to work with. So I'm going to rearrange what I've got. Put the numbers next to each other. 5.4 times 7 are going to be together. Okay. I'm actually going to use the times symbol. It's okay. Right here, dude. Thank you. And we have 10 to the negative 1 times, oops, got to remember to arrow out of the exponent, times 10 to the 0. Right? So all I did was rearrange so like things were next to each other. Numbers were next to numbers and things were exponents were next to things with exponents. According to our rules, when we have two numbers side by side to each other, they're the same base, what are we supposed to do with their exponents? If they're side by side and they're the same base, what are we supposed to do with their exponents? We learned it last week. We're going to add the exponents. Okay. Then we're going to use a calculator to solve this. So someone, please use their calculator and do 5.4 times 7. And tell me what the calculator tells you. What is 5.4 times 7? Okay, 37.8. Times 10 to the negative 1 plus 0. Remember, we're allowed to add our exponents. What is this exponent going to become then? How would we rewrite that exponent to pull it together? Pull the exponent together. What is it going to say? 10 to the what? Do the math on the exponent. Negative 1. Okay. Is our answer in scientific notation? Is our answer of 37.8 times 10 to the negative 1 scientific notation? Nope. Nope, it's not. What's wrong with it? Why is it not scientific notation? It says 10 to the. What went wrong? Why is it not scientific notation? It's not. Think back to the problems that we just got done with. There are two numbers in front of the decimal and there's only supposed to be one. So we have to jump our decimal. So there's only 1 in front of the decimal place. Which direction did I jump? We jumped left. So what are we supposed to do with our exponent? According to this, if I jump left, I add to my exponent however many jumps I jumped. How far did I jump? 1 spot. If I do -1 plus 1, what is my exponent going to say? What's a -1 plus 1? 0. Yep. Okay, we're going to go do it again. First thing we're going to do is move the numbers next to the numbers and the 10 to this next to the 10 to this. All right. This says 6 times 4. 6 times 4. You know how you say something and then you don't type it. And then we have 10 to the 6 times 10 to the -1. Arrow off. Okay, step 1, multiply the numbers, add the exponent. So I'm going to rewrite. I'm going to multiply the 2 numbers together. What do I get? 6 times 4. 24 times 10 to the, add the exponents, right? That was what the rule was. So what would that be if I rewrote it? (24) times what? 10 to the what? Do the math on the exponent. What do we get? To the 5th, yes. Now, is this scientific notation? 24 times 10 to the 5th. Is that scientific notation? No. Why is it not scientific notation again? What messed it up? It's got a 10 to the. Isn't that always scientific notation, 10 to the? Oh, 2 numbers in front of the decimal, because technically there's a decimal after this 24, right? An understood decimal. So we have to fix that understood decimal. We have to jump. Which direction did we jump? Which direction did we jump? Left. So what are we going to do with this one jump? How are we going to fix the exponent with that one jump? 2.4 times 10 to the what? Yep, back to the 6th. Okay, back to the 6th. All right, there we go. Rearrange numbers with numbers, tens with tens. 7.68. times 9, 10 to the second times, oops, didn't get off the exponent. That's the hardest part. Make sure you get off the exponent, times 10 to the 6. All right, do the calculator for the number. We're going to do our rule for the exponent. What is 7.68 times 9? What's the calculator tell us that is? Well, what's 7.68 times 9? You guys can use a calculator, it's fine. Read me the whole thing in the screen. Exactly like you see it. Okay, 69.12 times 10 to the 2 plus 6. Okay. $69.12 times, oops, times 10 to the what? We clean it up. Do the math for the exponent. Do the math for the exponent, please. Remember, we're adding the exponents because they're side by side. They're the same base. So we add their exponents. Is this scientific notation? No. Okay, so what do I have to do to fix it? This 9 has to be after the decimal point. What direction did I jump? And if I jump left, what am I supposed to do to my exponent? Add. So what's my final answer exponent going to be? 10 to the 9th exactly. Okay. All right. Well, that's it for notes. So hurry up and get that turned in. Save it, turn it in. Let's go on the assignment. Let's try and get the assignment done too. Okay. So I'm going to stop sharing.